welcome to Maths and Science by IITIAN channel. Now, in this lecture, I will be taking up pulley with a mass system. In the general pulley systems, we used to neglect the mass of the pulley, mass of the rope, and we used to calculate frictionless, massless pulley system in the particle system. Here, in this rigid body motion, we consider a pulley with a mass m. Let us consider that system and analyze it. And in the previous classes, I have explained what is the moment of inertia for a rigid body. When radius of gyration is known, it is I is equal to mk square. And there is a mass m1. The problem is made by me only. It is not taken from any textbooks. The mass of the weight, rather we can call it as, I have taken everything in SI units in newtons. Due to this mass, weight is equal to W1 is equal to 200 newtons, and here W2 is equal to 300 newtons, and due to this mass, W of the pulley is equal to 400 newtons, W of the pulley. We have not taken the mass of the rope into consideration as of now in this. This radius of the pulley R is equal to, in this I have taken 0.6 meters, and the radius of gyration of the system K is equal to 0.6 meters of the pulley system. Now, what we have to calculate? The acceleration. The acceleration of these masses. Because string is of the same length, as string length is not changing, the acceleration of both the masses will be same, but with direction change. Let us say W2 is moving downwards with an acceleration a, and W1 is moving upwards with an acceleration a. Then this is T1, tension in the string in respect of mass m1 and weight w1, and this is the tension in the string T2 due to mass m2 and weight w2. This w2 is acting downwards, this is acting downwards, because weights are always acting towards the center of the earth, which I have explained very clearly. And regarding these tensions, I have explained in the first class of my lecture in physics, that is forces and vectors, which I have explained very well. You please go through how to point out the directions. Tension always moves away from the mass, away from the point of under consideration. Because if it is towards the point of under consideration, it is compression. If it is away from the point, it is tension. Hence, this tension T2 is away from the mass m2, because we considered the mass m2. And when you consider the mass m1, in the rope, the tension will be towards top. This is also towards upwards. And the what you call the gravitational force is always towards the center of the earth. Hence, this is M2G is always downwards and M1G is always downwards towards the center of the earth. And we have considered the direction we have considered is for, we have at liberty to consider the direction of acceleration. Acceleration always acts in the direction of the force and direction of the motion. Because with common sense, we have taken that 300 newtons weight moves downwards and 200 newtons weight moves upwards. That is what is the common sense we have used. If we get the acceleration value with a negative sign, then whatever we have considered, that will reverse it. Except for the direction, it is not going to make any difference in the calculations. Direction. That direction, with our common sense, we have used. If you take a direction for W2 upwards and W1 as downwards, then you will get a value negative or positive. On that basis, we will correct the value direction of A. Now, in this question, what is the value of A? A is equal to how much and what is its direction? These two things. Here it is not ordinary pulley system. A weightless pulley is not there. There is a radius is also considered for the pulley and mass is also considered for the pulley, and radius of gyration is also considered for the pulley. That means we have to consider torque, we have to consider moment, we have to consider moment of inertia, and all those whatever we have learnt in the rigid body motion, equation of motion, that we have to apply here. How to apply and how to solve this problem, I will explain you now. Let us directly go for the solution. We have already almost drawn the free body diagram, which I have already explained how the forces are reacting. Hence, we need not do it again. Here, weight of the pulley what I have given, (400 newtons). That means mass of the pulley M by G, W by G. W by G. This is equal to W. That is equal to 400 divided by 9.81. Either you can calculate with 9.81 or you can round off to 10 and as per the question given in the examination. This will be approximately 40.7 kg. This is the mass of the pulley. Radius of the pulley is equal to R is equal to how much I have given? 0.6 meters. Radius of gyration, these are the given values what we are writing. We are not writing anything. We are not solving here anything. Radius of gyration K is equal to 0.6 meters. M1 is equal to W1 by G. W1 is how much I have given? 200 newtons. 200 by 9.81. Or you can make it as 10 also if you like. That is 20.39 kg approximately. M2 is equal to W2 by G, that is W2 how much I have given? 300. We are only writing what is given in the problem. We are not at solving the problem. 30.58 kg. Now, let us say T1, T2 we have already defined. Tensions are T1, T2. Tensions in strings. This is what we have assumed, T1 and T2. Acceleration of masses is equal to A, let us say. Then what is the free body diagram for M1? Here it is M1. This is M1G or W1 downwards. This is T1. This is A. This is M1A. The net force, what is Newton's second law? Net force is equal to F net is equal to M1A, with which it is moving upwards, that is equal to, because it is moving upwards, it is T1 minus M1G. Do you agree? These are the forces, external forces. This is the net force. Please try to understand this. Very, very important. If you don't understand this, this is F net. These are the external forces which are acting on the system. Forces assumed acting on the system. F net is the net force resultant, net. Net force is in the vertical direction only. That net force is equal to upward force minus downward force, T1 minus M1G. Did you understand? These people make a mistake stating that upward forces is equal to downward force. They will add M1A also. T1 plus M1A is equal to M1G. That is wrong. Please do not make mistake. M1A is net force. Net force is upward forces minus downward forces, in which not like upward forces is equal to minus downward forces, it is like net force is equal to the force in the direction of the net force minus force in the opposite direction of the net force. I will write here, net force is equal to, don't make mistake here, is equal to force in the direction of net force minus force in the opposite direction of net force. Don't forget this, please print it in your mind. Very important concept. Important. Here, you please, if I take 2 minutes also, it is worth. Here, I will draw the diagram again. Only external forces I will write here. Net force will be, because acceleration we have shown it as upwards, acceleration we have shown it as upwards, that means movement is upwards, hence net force is upwards. In the direction of net force, what is the external force acting? T1. In the opposite, what is acting? W1. Which implies F net is equal to T1 minus W1. This is equation 1. What is F net? F net is nothing but M1A, because mass of the block into acceleration M1A, that is equal to T1 minus W1. That implies T1 is equal to M1A plus W1, which we can write it as equation 1. Instead of this, we will write this as the equation 1. Okay. Similarly, free body diagram of this is M1. Now, we will go for the free body diagram of M2. Here it is there, downwards W2 towards the center of the earth, upwards is T2, and acceleration is downwards, hence net force is downwards. Net force is towards the direction of the motion. This is F net 1, this is F net 2. F net 2 is how much? F net 2 is equal to M2A. That is force in its direction minus in its opposite direction. You please see the difference. We are getting different equations here. That implies T2 is equal to W2 minus M2A. This is equation 2. Do you agree? Now we have got two equations. T1, because we have to find out the tension in the string, then only we will be able to find out the acceleration, and then we can apply this to conservation of momentum, conservation of what you call, we have to find out the moment of inertia. From there we have to find out the moments, then we have to apply the principles of equations of motion. Lot of issues, lot of steps are there. This is the first step. You should not make mistake in this step. It's very, very important. T1 is equal to M1A plus W1 I can call it as M1G. This is equation 1. Then T2 is equal to M2G minus M2A. A we are not aware, M1, M2 we are aware, and G also we are aware. These are the two equations we got. Now, the torque. Now we will go to the pulley. This is about the masses M1 and M2. Now we will go to pulley. Pulley, what is given? Mass of the pulley is equal to, what is the mass of the pulley given? The weight of the pulley is given, mass of the pulley is not given. Mass of the pulley is 40.7. We have calculated already. M is equal to 40.7 kg. Radius of gyration is equal to 0.6 meters, which implies the moment of inertia of the pulley is equal to mk square. That is 40.7 into 0.6 square. Are you able to understand? That will be around 14.7. We will make it up to 1 digit. Don't make it 2 digits and 3 digits. It will be very long. This is kg meter square. Now, I have discussed, once we have this moment of inertia, then can we find out what is I by R square? R, radius of the pulley is in this particular example, I have taken K and radius as 0.6, but it may differ. 0.6 meters radius of the pulley I have taken. Then, what is the value of I by R square? That is 14.7 divided by 0.6 square. That is about 14.7 . No, it is 40.7. 40.7 kg. I by R square is kg. Here, force on pulley is equal to I by R square into A, because I by R square has got the mass units. Here R I have taken and radius of gyration I have taken as same, hence you are getting similar values, but it will be different in different examples. You please try as a homework. Force on pulley is, this has got units of mass, this has got units of meter per second square. This is mass in this sense, it is kg. So that it is force. This has got Newton. This is a force on pulley, net force, and net force on the ropes, net force due to rope and masses is due to tensions in rope is equal to T2 minus T1. Do you agree? For equilibrium, T2 minus T1 is equal to I by R square into A. Which implies, what is T2? W2, sorry, we'll change the color of the pen. W2 minus M2A minus W1 plus M1A. This is what? T1 is M1A plus M1G, M2G. M2G I have taken it as W2. This is W1. W2 minus M2A minus W1 plus M1G. This is not this one. Let us this one is W1. W1 plus M1A. This is equal to I by R square into A. This is the final equation of motion. From this you can easily solve the value of A. What is W2? W2 we have taken it as 300 newtons minus what is M2? M2 we have taken it as calculated as M2 is 30.58. Don't worry about the numericals. Minus 200 newtons minus M1 is 20.39 into A is equal to I by R square. What is the I by R square? 40.7 into A. From this it is a single equation with single variable. From this we can conclude that A is equal to 1.09 meters per second square. It is a positive value, so that the directions whatever we have assumed they are correct, and acceleration of the both the masses are same, M1 and M2, and they accelerate at the rate of 1.09 meters per second square. Now I'll just give a final procedure for this. This pulley system problem is very important. The final I will give you. First step is to assume motion of masses and acceleration direction. First assume the acceleration direction. Then write the equations for tension in the rope. Then calculate I. From that, calculate I with mk square. From that, you get I by r square. Then equate net force due to tension, that is equal to either T1 plus or minus T2 is equal to I by r square into A as per the directions assumed. Then last step is solve for A. If A is equal to positive, the assumed directions are correct. If A is equal to negative, it should be done at the last stage. Then change the assumed direction. You need not do the whole problem again, just only change upwards, downwards. Because the question is asked, what is the magnitude and direction of the acceleration? Here answer is, magnitude is 1.09 meter per second square. Acceleration direction is equal to for M2 it is downwards. This is what is the answer. I want to close this particular lecture now. Thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody. When you consider the radius of gyration, why I have taken up that particular lecture before taking up these numerals? Because you should not get confused from where radius of gyration has come. And the relations I by r square, that you can definitely check up from what you call your previous lectures which I have given you, that I have in detail explained all the relations and compared the linear accelerations and angular accelerations, linear velocity, angular velocity, everything I have done there. Please view those lectures and understand from where I by r square has come. I by r square has the units as a mass, so that when you multiply with acceleration A, that gives a force because of the pulley mass, that is I by r square you have to find out. I is to be found out from mk square. From there, by knowing the radius of the pulley, you can find out I by r square, that you multiply with A, that is the pulley equation of motion, and the equation of motion of M2 and M1, that is T2 minus T1 as per the direction of the motion you have assumed. Thank you for listening to me. Best of luck to everybody. Thank you for hearing my lecture and also viewing my lecture. And if there is a value addition because of this lecture to you, please subscribe to my channel and share my channel's videos to others, and also please subscribe to my channel. I am from Maths and Science by IITIAN. As I told already in the previous class that I will be going for road embankment. Lecture I will be taking up in the next. Actually, this lecture should be road embankment, but I have given little bit preference because I have covered I is equal to mk square and other things. Then I thought, okay, let me couple the this rotational motion and pulley mass in this and explain the pulley system. Thank you. Best of luck to you. Please subscribe to my channel Maths and Science by IITN and share my videos.